Well, good morning, or good afternoon, good evening to everybody, depending on which time zone you happen to be in. For me, it's a very early good morning to you. I'm Brent Hall, the Director of Education and Research at Esri Canada, and I'm pleased to be able to introduce today's four speakers from the education community. Before I get to the first speaker, I'd just like to wish you all a very happy GIS Day. And for those of you who don't know, it's also Geography Awareness Week. So a very happy Geography Awareness Week as well. Now we have four speakers lined up for you in this part of today's celebration. And we've chosen these speakers carefully. They represent each a particular level of the Canadian education system. We have one from the elementary system, one from the high school system, one from a community college, and finally one from the university network. So we're well represented in terms of the various segments of the education system in which GIS is taught. We also chose the speakers so that we have a good regional coverage from Calgary in the west across to Nova Scotia in the east. And the speakers were also chosen because of their reputations and because they're known to be among the leaders in GIS education in the country. So without further ado, I would like to introduce today's first speaker, and that is Professor Lynn Moorman from Mount Royal University in Calgary. And Lynn is going to speak to us today. The title of her presentation is titled From Rocket Science to Pocket Science. So without further ado, I will pass it across to CVent and we will hear from Lynn.
Thanks very much, Brent, and thank you for inviting me to present here on GIS Day. I'm going to be talking about from rocket science to pocket science, and that really encapsulates GIS education for me now. We're teaching students how to map with satellite images and then having them take their own digital devices and become agents of citizen science by going out and mapping the environment in their community. So this has really changed how we teach GIS and our pedagogical practice. So that's what I wanted to speak to you about today. My work is really in understanding and unpacking the skills and knowledge that learners have to draw from in order to make best use of geographic technologies like GIS. This interest is situated at the intersection of learning sciences and geographic technologies, and it's a great niche because we've had such advances in both these fields, and they really, really do inform each other. In the learning sciences, understanding spatial cognition better informs how people think geographically, which is important in building GIS instructional sequences and the pedagogy or how we teach, especially in K-12 environments, but it certainly fits right up to post-secondary. We're also better understanding how spatial thinking skills enhance outcomes in different areas where mental models or 3D rotation is important. So think in engineering, chemistry, biology. On the technology side, the easier interfaces, cloud services, and students being up who we can teach to and how we teach GIS. And just an example of why that spatial cognition is so important. Developing a geographic sense or spatial sense, we actually have to learn that nadir perspective. We're looking straight down. And here's a great example of a student who's just in the midst of that. So if you look at the roads, they're from a nadir or top-down perspective, but then you look at the buildings and they're oblique or from the side. And so they haven't quite got the full sense of what a top-down image student. So this has implications because everyone develops at their own rate. This has implications for how much do we assume people understand when they're looking at satellite imagery in particular. ArcMap and ArcPro and all the associated extensions, there's so much capability there that we can't possibly teach it to the students, not all of it. The root word of technology is techne. It means when they're looking at satellite or human capabilities. And so for GIS, that means ArcMap and extending our ability to think spatially and build our perspective. Through user interface studies and even eye tracking studies of students, as they start to use geotechnologies, I can see that there's a core challenge, and that's in students being able to understand geographic data and even at the start ask spatial questions or take a spatial approach to a problem. So what we start to use for is really understanding how students are looking at a geographic image. You can see that there's eyes on the left-hand side, and that's the actual student as we're focusing in on their gaze and measuring where they're gazing and how long they spend at that gaze, and then tracking where they go to next. It tells us a lot about what they're thinking about the imagery and where the difficult bits are. So we really need to start building some student capacity to best make use of the technology, and that involves building much stronger pedagogical supports as well. So fortunately, this is where the advances of things like ArcGIS Online and story maps are critically important. The mapping software is not limited to experts anymore or expensive labs anymore. It's accessible and fairly easy. It's flipping our course sequencing upside down and even affecting our pedagogy. So when ArcGIS Online first appeared, we added it to the Advanced GIS course, letting the introductory students just focus on getting experienced with ArcMap and then adding this other piece on later. But the ease of ArcGIS Online means that as educators, we can focus on the spatial thinking and reasoning, and the students get really interested in what GIS has to offer before we immerse them in the world of Python and maybe spatial data science. So this helps with making GIS appealing to more students. We've moved from a series of 3 progressive courses in ArcMap to now including a general education course in spatial innovation. Also a spatial thinking course using ArcGIS Online as a way of enhancing and applying the spatial thinking concepts in geoinquiries. Students have been able to jump into ArcGIS Online and create meaningful and useful community applications. Some graduates have taken their knowledge and transformed it into successful business concepts. Another way that we're looking at building spatial thinking in K-12 is to use physicalizations of GIS. With a team from computer science at the University of Calgary, who specialize in geovisualization, we've created physicalizations of GIS, or hands-on models of the Earth, conforming to the exact Earth curvature and allowing for hands-on visualization and analysis of different layers of data, and done the assessment of this in terms of how students reacted to it. So that user testing in geography classes in Australia has indicated that the students are really enjoying the hands-on component. They appreciate that curvature as it shows the true shape of the Earth, and they see it as more realistic than two-dimensional representations. They also said that they saw it as a helpful bridge to the world of GIS. So with this work, we also start to see where there's challenges in how students understand the concept of overlay, what types of color representations and combinations work best for student understanding. We're also developing tactile models of data, particularly remote sensing data, for geospatial training in Inuit communities in the Canadian Arctic, and learning about how different sensory data can affect learning. In this particular project, I'm working with Smart Ice, a social enterprise organization, and we're co-designing geospatial education programs with Inuit community members. And the goal is to enable them to create frequent sea ice safety maps in their communities, and they'll be using ArcPro. They'll be combining imagery with their own sea ice knowledge and current and past observation data. You can see that we actually go out on the sea ice. This is mapping out the size of a pixel that they would be using in their imagery. So it's my belief that you have to have a fundamental connection or understanding to that land being studied. So every GIS class I teach has a field component whenever possible. And of course, in Calgary, that often means that there's snow involved in our GIS classes. So with the new field tools and apps provided by Esri, we can now do that. We can get the classes into the field. And this is where GIS really becomes pocket science. My advanced GIS course has a community service learning designation, and GIS is a perfect course to address real-world problems faced by community members. Through access to authentic data and tools to capture data and means for sharing our solutions with our partners, it's just a fabulous solution. So we always meet our partners on the land. My classes have worked with the Cross Conservation Area, a Bluebird Nestbox monitoring group, the Ghost River Valley, and recently the Ellis Bird Farm. Every student does their own research project, but the class is set up like a GIS consulting company. They need to help each other, brainstorm to solve problems. The courses have been so successful that we've had communities extend the student projects into paid work terms for the students. The evolution of GIS has enabled the same type of projects in K-12 schools. In the spring of 2019, a local teacher asked if I could help with a grade 4 wetlands project. The students became spatial scientists. They all had ArcGIS online accounts, and they explored open city data and started asking more and more questions. They compared watershed boundary data to their own observations and quickly realized that not all data matches or is created equally, and that ground truthing is really, really important. They looked for schools to collaborate with who had similar access to wetlands, using a proximity analysis, of course, and eventually presented all of their findings on the health of their local wetlands to about 800 industry professionals at the local Esri user conference. They've been highlighted across Canada and the US for their innovative work, as has their incredible teacher from the Calgary Board of Education, Alison Katsko. So that was the spring of 2019. In the spring of 2020, COVID hit, and our classes were suddenly shut down and collaboration opportunities closed up quickly as everyone struggled to get online. Some students moved to ArcGIS Online, and everyone went to story maps, which actually increased access to the projects to everyone, especially our partnering communities. I always promoted troubleshooting and looking through forums for GIS help instead of asking me all the time, and the students quickly adapted to being their own guides as they tried to finish up their projects. They used learning resources and Esri support, and I was astounded at the quality of the GIS projects completed, as were our community partners. One student actually transformed their project into a COVID data hub for Alberta, catching the eye of the Esri staff and Alberta Health before he had even submitted the project to me. So talk about using, real world problems and authentic data. It was a fabulous experiential learning opportunity. So I'm really thrilled to see where all of this goes next, and also excited to hear how other presenters are using GIS in education. So thanks for engaging with me today. Please do have a happy GIS day.
Okay, great. Thank you, Lynn. That was an outstanding presentation. I'd like to step one province to the east into Saskatchewan and introduce Andre Boutin-Maloney and Elizabeth Ingram. Andre and Elizabeth are professional educators at the Bert Fox Community High School in Fort Capel, Saskatchewan. And they're going to talk to us about an outstanding project they did with their students for Treaty 4 area, where they produced a story map called Finding Common Ground. And so without further ado, I will pass control over to CVent, and we'll hear from Andre and Elizabeth.
We are happy to share our experiences developing Finding Common Ground, a treaty walk of Fort Capel, Saskatchewan. Our work builds on the work of anti-racist educator Sheena Coops, who undertook a year-long inner work project where she walked the 30 minutes to and from school, meditating and blogging about treaty. So simply, a treaty walk is a walk, stroll, or roll with treaty on the mind. It is a process where we examine the world around us through a treaty lens. For example, look at the street names around you. Who or what are they named after, and why do we honor them this way? What role do they play in colonialism? Coops' realization that every place in Canada has a treaty story evolved into a guided treaty walk, where participants could be led to physical locations in the community where they were prompted to think about those particular locations in respect to treaty. Much like a nature walk, but instead of stopping to look at a particular flower, a participant would read a quote or question designed to get participants thinking about our collective responsibilities to treaty. It became a pedagogical proposition focused on identifying and disrupting colonialist thinking. For example, the idea of a park is tied to a European worldview of separating nature from people. There weren't parks in Indigenous North America because people in the land were not separate. Coops and her adult 12 hosting and disrupting Tamwakote Yisiniwi Wow class brought fellow students, teachers, and community members on this walk.
Last year, Elizabeth and I were given the opportunity to team teach an outdoor education class. Part of the learning included reading, interpreting, and making maps. You might be surprised to hear this, but much of the mapping in schools is tied to the social studies curriculum. Many students are bored when learning about landforms and physical geography because they're taught as if all that matters is learning to define and recognize capes and hills, glaciers. The maps they color are often assessed on the basis of neatness and whether or not the cities and rivers are correctly labeled. They learn mainly through visual means, rarely developing a feel for places through the use of their other senses and imaginations. We wanted to create a distinctly different mapping experience for our students, not just mapping for the sake of mapping, but one that would meaningfully connect their learning to both the physical and social environments. We looked at mapping COOPS' Treaty Walk as an opportunity to do real-life mapping and to incorporate social justice work in our classroom. We initially started by working with Esri Canada's GIS materials and then pitched the idea of converting the Treaty Walk into a digital self-guided tour for the public. It was a bit of a tall order, and honestly, I don't think any of us really knew what we were getting into at the time. But they figured it was something they could do. We quickly realized that creating the story map was so much more than a mapping exercise. It was deep learning, and we were going to follow it.
We started by plotting out the original points along the walk and discovered that some of them were really spaced out. We also found that there were some major points missing, such as the treaty foregrounds and the All Nations Healing Hospital. This led the class to take a closer look at our community and to think about how we could add new locations and include their relationship to treaty. There are many layers of understanding to explore with treaties, both for students and for us as teachers. There were many times where we and the students swapped roles, both learning from and teaching each other. As we dove into the history and context that surrounded each point, we often had to stop and unpack our understanding in order to consider how to convey it to someone on a self-guided tour. We knew we were going to be putting it out to the public, so there was some real pressure on all sides to do a good job of it. We became citizen researchers, investigating each topic, adding and moving points and data along the route, studying historical documents, visiting museums, and consulting with local knowledge keepers and community members. In addition to updating and rewriting parts of the original work, the story map provided a new opportunity to incorporate photographs, videos, and links to websites and news articles. The classroom walls looked like one of those detective movies where the police had photos, notes, and lines pinned up all over the map.
Finding common ground, as it exists right now, continues to be a work in progress. It continues to evolve as we add and edit bits to date. It's developed a bit of a life of its own, really. Part of our truth and reconciliation work is to reevaluate current beliefs and understanding, especially those based on mythic historical perspectives. A lot of that work is happening in schools today, but the general public has a lot of gaps in their understanding. We create a pamphlet with a map and a link to the tour and place copies at the Provincial Park and the Community Visitor Center to help bridge the understanding with the community. In addition to that, the digital treaty walk is being accessed by educators for use with their classes, by schools for professional development, and is being used by several education classes at the University of Regina as a potential new pedagogical process. While we feel that there's something special and significant about being physically present in each location as you visit it while doing the walk, the digital format has become even more useful under COVID. It continues to serve as a learning tool despite travel and gathering restrictions. We are interested in following how it's being used to virtually visit and be mentally present.
We're happy to hear that it's inspired educators to begin developing their treaty walks in their own communities. And that's what we both would like to leave you with. This is something that anyone can do. It can start with your own personal walk, looking for those connections. A great reference to start with is the Treaty Essential Learnings from the Office of the Treaty Commissioner. You can start with a single point or topic, and you can easily level it for your audience. At the high school level, we are talking papal bulls and doctrine of discovery. At the kindergarten level, it can be as basic as gathering on the land and sharing, especially to discuss what it means to be a treaty person.
We had a lot of fun researching and creating this together with our class, and we want you to know that
you can treaty walk too.
Great. Thank you, Elizabeth and Andre, showing us how we can all treaty walk and roll by following the same path that you followed to develop this great application with your students in Fort Capel. We're now going to step over a province in Manitoba and land in Ontario. And for our third presentation, we're going to hear from Tony Cushman, who is the elementary chair and a grade 3 teacher at Rolfe Road Primary School in Toronto. Tony's presentation is titled Fieldwork in the Elementary Playground, and so I will now pass over to hear from Tony. Thank you.
Hi, my name is Tony Cushman, and I'm a grade 3 teacher and the elementary chair of Rolfe Road, a primary school in Toronto, Canada. I want to tell you about how my grade 3 students use GIS technology to uncover mysteries hidden within our school playground. On second thought, why don't I let my students explain?
Here, I'll hear from Mr. Cushman's class with a small favor to ask. Don't worry, we're not trying to ask to borrow any money. You see, we are doing some research about recess at our school, and we need your help. Seriously. We have created a survey with some questions that we want you to answer. Let me give you an example. Questions like, what kind of games do you play at recess? Who do you usually play with? And where in the playground do you usually play? And also questions like, do you feel included at recess? Do you feel excited? And, can I go to the washroom now, Mr. Cushman? Wait, forget that last one. Every single class at Ralph Road will be invited to our classroom during the week of November 11th to take part in our recess survey. And do you know what the best part is? You don't even need to bring a pencil. We'll hook you up with an iPad, and you will scan a special QR code to get started. Our survey even includes an interactive map of the playground that you would use to pinpoint your favorite place to play. Now I know what you're thinking. What's the point of all this? The data we collect from the survey will tell us how recess is going and what our school can do to make recess at Ralph Road even better. And we will also be sharing all the results with all of you so that you can take a look for yourself. What a cool math project for our whole school to enjoy. We can't wait to work with all of you.
All 339 students at our school, from kindergarten to grade 6, visited our classroom through the course of a week to complete the recess survey that we had designed. Our entire project, from the designing of our survey to analyzing the survey results, was led by my grade 3 students. We designed our survey using Esri's Survey 123 software, and the results were all then accessible through a feature layer in ArcGIS Online. This is a scale map of our school playground that my students constructed using their measurement skills to share some survey results. Next, we teamed up with the grade 6 class to help us analyze the survey results further. Students use ArcGIS Dashboard to create digital graphs and maps representing their data. They then created story maps to share their conclusions with our school community, our principal, and our superintendent. Our fieldwork project allowed my students to apply academic skills from across the curriculum to an authentic and meaningful context. Most importantly, this project taught my grade 3s that even at a young age, they have the ability to answer big questions and solve real-world problems. Now here's the real question. What could you investigate at your school? And what might you discover as a result? All right, thank you, Brent. This is the live version of me, and you can tell because I'm wearing a different hat. And I want to tell you a bit more about the process behind our project. So it all started with this big question. What do the experiences of the students in our playground tell us about our school? And we know that recess in an elementary playground is a really chaotic environment. And we thought that we could use the inquiry process to find out a lot about the culture of our school by asking questions to all the students in the school. So that's the reason that we chose to focus on recess, because in that unstructured environment, choices that the students are making in terms of the activity they play, who they're playing with, where in the playground they're playing, can tell us a lot about the individuals and the culture of the school. And a big part of it was involving the students in this conversation because school principals always collect data about the achievement and well-being of students, but it made sense to include the students because their voice is important, obviously, and they can learn a lot of math and social studies skills through the process. So we started off thinking about some of the benefits of recess, and we brainstormed questions that we could ask the rest of the student body through a survey. And you can see on the screen now the brainstorm that my students engaged in. We're asking demographic questions as well as questions about where do you play, who do you play with, and actually we originally were going to use Google Forms for our survey, and then I discovered Survey 123, which was perfect. And one reason that it worked so well is that over the course of a week, we were able to engage every single student in our school with the survey, and this is actually what it looked like when students were answering our survey. They used iPads to scan a QR code that were on the desk, and then they could use the iPads to answer each of the questions, and the results would come up in real time. This is what the survey looked like. So we started with demographic data, like asking the students their grade, their teacher, their gender, and a question here about what students usually do at recess, how often they try new activities, how often they have nothing to do at recess, how often they play with students from different classes, different grades, different genders, and about whether or not they can find students to play with at recess. And this part right here was key to the process, and another reason that using Survey 123 was perfect for our project, because students were able to pinpoint their favorite place to play or where they usually play. So you're looking at a satellite image of our school playground at Rolfe Road. And right now the student is zooming in on the monkey bars and pinpointing this spot as the place that they love to play at. These questions are emotional questions, asking them how often they feel happy at recess, how often they feel excited, how often they feel included. This question expands if the students say that they sometimes have problems at recess, to ask some follow-up questions about that. And if we move on from here, we can see that there's one more main question, which is a 10-point well-being survey with yes or no questions. There's one open question at the end, and then we wanted the survey to be anonymous so we could explore the data by demographics without revealing the identity of each of the respondents. So we used the secret code for each of the students. So this is a look at some of the results. This is actually a heat map of our playground, and we can see that the monkey bars is one of the hottest spots to play in the playground. We can look at the results by activity, and each of these colors here represent different activities that students have chosen. The red represents competitive games. We can see different clusters of dots based on the activity that students have chosen to play. And coming up next, we can actually look at a map by gender and see if the students were able to look and see if they noticed any patterns about where boys versus girls are playing in the classroom. So this is a look at that right here. And finally, by grade, we can see that the kindergarten students are the red dots. And for example, they often play in the front of the school in the playground there. So this was really neat, obviously, for students to be able to look at maps to see the results. And it was a lot less abstract than some other forms of representation. We got into story maps, and before the students made their own story map, we made one together to model the process. These images are showing the one we made together about the activity that students chose to play. We can see that the red for competitive games is by far the most common activity that students play. This is a stacked bar graph, and it's showing from grade 1 to grade 6 the activities that students choose to play. And we can see that those competitive games actually get more popular as students age and make their way through our elementary school. We wanted to get even deeper and look at a stacked bar graph by gender. And actually my students were interested to notice a big difference between boys and girls in terms of the activity that they were choosing. And actually competitive games don't seem quite so popular for the girls. This is a look at boys versus girls for the activity they choose. And we can actually see my students notice that competitive games get very popular as the boys get older, whereas for girls, they spend a lot more time standing around and talking with other students. So we actually teamed up, my grade 3 class teamed up with grade 6s in order to get deeper into the data and make these dashboards. This is a grade 3 student with a grade 6 student, and they're making a dashboard with a map and a bar graph. Each group focused on a different survey question. We don't have time, unfortunately, to look at all of the story maps that students created, but we're going to take a look at one. And this one was focused on how often do you play with students of a different gender. So this whole story map you're looking at now is one that was created entirely by the students. And this group is saying they hope that students are playing with other genders, because if they're only playing with the same gender, it's greatly limiting in terms of who they're engaging with. These students noticed that half of the students in the school said they sometimes play with different genders, and a third said that they never do. So they created a stacked bar graph here. These students have included a map where they can look at the results based on the different responses on a map. So right here, we can see these are the students that said they never play with other genders. What was awesome is that the different groups were able to then meet with the superintendent and principal and share their conclusions and give some suggestions. This group is saying that they think the school should offer more structured co-ed games so that it can encourage more genders to play with one another. Thanks so much for taking a look at this story map and hearing a bit about our project. If you want to learn more, we're going to post my email and a link to the story map in the chat. Thank you.
Thank you, Tony. That was wonderful work you've been doing with these young budding GIS professionals at Rolfe Road. We're now going to jump right out east to Nova Scotia. And for the final presentation today, we are going to hear from Dave McLean, who is an instructor at the Nova Scotia College of Geographic Sciences, which is more commonly known to all of us in the GIS community as COGS. And Dave is going to be speaking to us today about teaching GIS-related technology at COGS during COVID-19 times. So I will just turn control back to CVent Central and we will hear from Dave. Thank you.
Hello there. I'd like to talk a little about teaching GIS technology during COVID-19 on this GIS Day 2020. Thank you, Esri Canada, for the opportunity for us to present today. If you'd like to follow along or rewatch later on any device, you can use this link, bit.ly/cogsesri2020. Here's some information on working and learning and teaching from home during a pandemic. Where is the Center for Geographic Sciences? It's in Lawrencetown, Nova Scotia. We're part of the Nova Scotia Community College. We host programs in many geography-related disciplines, with a variety of intake streams. I'm Dave McLean, one of the GIS-related faculty at COGS. Until COVID-19, our programs were completely in person, but things changed radically for 2020/21. Some programs are blended with small groups of students at COGS using specialized equipment, but most are completely at home. Here's a map showing where most of our GIS, remote sensing, and geospatial data analytics students are located. They're spread across Canada, with one in each of the US, Nigeria, and India. The inset map shows locations across the maritime provinces. Here's some information from some of them. Note that the students have remote access to computers at COGS. They also have a selection of geospatial software on their personal computers as well. Danielle in Halifax says, I like the way this program is delivered, having shifted to an online environment. And due to the nature of its implementing obtained knowledge using computers, it doesn't matter where the students are, and there are lots of ways to ask questions. A student in India, Yogesh, says, it's evening here when it's morning there. I like the program so far. Love the fact that GIS can be so diverse and so intertwined at the same time. Microsoft Teams is very helpful. He likes the recordings. He says it's also useful for chatting with classmates and faculty. Brightspace is a nice tool to manage course structure and to view grades all in one place. Some notes from Madeline of Halifax, also a GIS student. She likes the flexible learning environment using Brightspace, remote access to school computers, and MS Teams. She finds the courses engaging and lots of opportunities to collaborate with classmates from many different backgrounds. From Prince George, British Columbia, Juliet adds, the COGS Advanced Diploma in Geospatial Data Analytics will equip me with skills to analyze and discover useful insights in the forestry domain. Brightspace has made course content, due dates, and submissions quite streamlined and easy to organize. Her workspace has a candy jar for sugar pick-me-ups. It's currently in need of a refill, she says, as a traditional bulletin board for reminders. And a handy SQL reference book. Some notes from Shelley in Halifax. It took some effort to set up Teams, Brightspace, remote access, and the software combinations, and to figure out an efficient workflow. Once established, they help organize study very well. The skills of GIS are expanding the scope of my current job, which is processing data for academic uses. Meanwhile, here are some views in this virtual classroom that I have. It's divided into 3 groups within the Microsoft Teams environment. In addition to career opportunities in industry and government, some students choose to further their studies at the master level. One of the unique opportunities is a joint master with Acadia University in the Master of Science in Applied Geomatics. Here's an example project that Matt worked on in Grand Pré, Nova Scotia. Regarding their silage production and corn heat units, Matt worked with a high-resolution digital elevation model to help correct the areas in the field that are more affected by water-saturated soils. Students also have the opportunity to be involved in the Esri Canada Centres of Excellence program. 6 of our students will be associates. They'll use developer software, participate in extra GIS training, and contribute to blogs. In the spring, those 6, along with other students, will compete in the Cross Canada App Challenge. This is a week using open data, creating a geo app, and pitching it with a video. This video shows 3 ongoing construction projects at COGS: our solar farm, our Geospatial Analytics Innovation Accelerator and 40-bed residence building, and our high-efficiency wood pellet burner building. The Geospatial Analytics Innovation Accelerator is a hub where industry, faculty, and researchers can find sustainable planning approaches for resource-oriented businesses. Key partners include agricultural technologies, aquaculture, climate, fisheries, and the forestry sectors. As part of their education, students may work as interns between academic terms, so their learning is integrated with real-work experience. Industry collaborators have direct involvement with new talent. And our campus community provides services for professional learners. So, although COVID-19 disrupted our teaching methods, our students are learning, and building goes on without disrupting that learning. Industry, we're confident that the class of 2021 will be very ready to enter the workforce. Thank you for your time, and thank you, Esri Canada.
Great. Thank you again, Dave. It's wonderful to see that not only COGS, but most of the universities and schools across the country are coping as well as they can under these very difficult conditions that we're working with and living with at the moment. So I would like to thank all of the speakers, the 5 speakers that we've had this morning. They will now be coming back for a Q&A session. During the presentations, there were questions and comments coming in. I'm going to start actually in reverse order, and we're going to come back to you first, Dave. The question for you, one of the questions that's come in is, what's the greatest challenge that you've faced at COGS under the COVID-19 times? You can unmute yourself as well. Good.
Thank you. Thank you for that question. It's a really good one. A few things come to mind, and the fact that there's some software that we've loaded on people's personal computers at their homes, but not all. All of it is loaded on machines here at COGS, and so the students have remote access to that to make things work. And our IT group has done a lot of work to make sure that that sort of stuff works. pretty well. It's a lot going on, but getting the students up to speed on remote desktop has taken a little bit of time at the first of the year. Another thing that comes to mind very much is that at-home internet speed and reliability is certainly an issue for some of the students, whether they're doing things with the remote access or with some of the online technologies. It is an issue. But we have a great group of students, and they're having lots of fun learning about ArcGIS Pro, learning about ArcGIS Online, ArcMap, remote sensing, programming technologies. So it's coming together quite nicely. Thanks again for the question.
Good. Okay, no problem. Great to hear. So heading west rather than east as we did with the presentations, Tony, next to you at Rolfe Road. One of the questions that's come in is, do you teach only GIS to the grade 3 students at Rolfe Road, or do you actually sort of introduce GIS to students across other grades at the school?
Sure, thanks for the question. I think that our project shows that GIS is something that doesn't need to just be restricted to older grades such as junior high and high school, but can be applied to the elementary grades. I'm actually teaching grade 1 this year, not grade 3, so even younger students, and we are finding a way to use GIS in our classroom. The hope is that more elementary grades get engaged with this, and the hope is also to expand our fieldwork project so that other schools, other places in the country could try the same thing, because I think it would be really interesting to compare the data.
Well, if you teach the grade 1 students a third as well as you've taught the grade 3 students with the technology, we'll look forward to seeing great things from them. So,
thanks a lot.
Yeah, okay. Thanks very much. And across to Andre and Elizabeth now in Fort Capel. I love the story map that you've produced. I think it's great, and I'd really like to see this approach deployed in other treaty areas across the country. And thank you for your contribution. It's really fantastic. But if you could, people are asking, what was the most difficult aspect of doing the treaty walk with the students? Could you comment on the challenges, the real challenges that you faced, not only as far as technology was concerned, but also as far as introducing the students to it in the context of a really important social issue in the country?
Sure. Thanks for the question. I think one of the hardest parts for us was to know how deep to dive into it. There's a lot of information to unpack with this. And being in that we're located in Fort Capel, it's where the signing of Treaty 4 occurred. We have a lot of history. And so we had a lot of community members come and bring a lot of ideas to us, which we were very grateful for. But in the end, we had so much to do. I tried to do the treaty walk myself, and it was like 3 hours long. And if we wanted to do everything we could, it would have been 6 hours long. And so we also spoke about breaking it down into grade level, because right now it's quite heavy and more of a senior level. And we thought maybe we could break it down into grade level more so that it's more doable for everyone that way. So it's just a huge project that we could do. And so it was a lot of work with our students trying to figure out how deep to dive, basically.
And also
that's great. I actually was, sorry, Andrea, I was part of a workshop yesterday for Indigenous communities across Canada, and I made reference to your story map at that, and there was a lot of interest in it. So sorry, Andre, you were going to comment.
I'll just add that the process of learning deeply about treaty can be unsettling, and I think that's one of the first steps in being an advocate, is to be unsettled and to be uncomfortable. And we often, like, Sheena Coops is kind of our guru, and she always encourages us to go forth and be awkward. And so it's trying. That's the challenge. It's going to be a little uncomfortable, but it's good work.
Excellent. Thanks for the answer. And so last one with the person we started off with across in Calgary, and I think you win the prize today for the catchiest title for your presentation. Science to pocket science. That's great. And you certainly showed the transition from one to the other in the presentation. One of the questions that's come in is really related to how widely the technology is used at Mount Royal. Is it confined to the geography department, or are you getting interest from other departments and other faculties on campus for use of technology?
Yeah, great question, Brent. One thing we really noticed with COVID was that all of a sudden GIS was the solution for continuing our physical geography courses. For one thing, doing field trips and doing labs. All of a sudden we could do that in ArcGIS Online and Story Maps. But I was also getting questions from across campus before COVID. And so I initiated through some internal funding in our university, something called the Spatial Sessions. And we gathered people from 18 different departments across campus who are all, in isolation, discovering GIS and working on it, everything from English to interior design to ecotourism. And so we've come together and we're working together on a campus initiative for this.
That's great. And just as a sort of rejoinder to that, you do a lot of work with K-12 groups in Calgary. How do you actually sort of build the outreach into the K-12 teaching community in the city from the university, through personal contacts or some other means?
Yeah, it's a good question because it's a challenge, right? I take a three-prong approach to this. One is using Esri's GIS Ambassador program that helps connect experts and even in industry and academia with K-12 teachers. Also through the Canadian Geographic Education Network, which is 25,000 teachers across Canada interested in geography. So of course, this is a power tool for geography. There's a regional representative for the provinces and territories. So great to connect with them. It's really good for sharing information and also communicating. And I guess my third prong of approach is just direct communication, inviting teachers in for professional development sessions at the university. That's easy and fun, and you just make those personal friendship connections too.
Right.
Also presenting at the Social Studies Association conferences.
Okay, that's great. Well, we're coming close to the end of our time this morning. So on behalf of the company and indeed the Education and Research Group, the staff that work with me, I'd like to thank all 5 of you for your presentations. We know that GIS is certainly in good hands at Rolfe Road Primary in Toronto, and we're looking for great things from the grade 1ers. We'd like to see everybody across the country who live in treaty areas walking and rolling, using for treaty walks, using Andre and Elizabeth's approach. Dave, the work you do at COGS and the other faculty there is well known to the community across the country, and we thank you for that. And Lynn, the diversity of the work that you're involved with and the great outreach that you do across many communities is really fantastic. So thank you to all 5 of you once more. And I guess we can close the session today just by wishing everybody a happy GIS Day. So happy GIS Day from me.
Happy GIS Day.
With the speakers, Dave is eating cookies. And so good luck with the rest of the presentations today, and we'll be in touch in the future. Bye from me.